Today we're diving into a technology that could completely rewrite the rules for clean energy. We're talking about a new way to make green hydrogen that isn't just clean, but could soon be the cheapest fuel on the planet.
And believe it or not, the secret behind this whole revolution is something you probably got in your kitchen right now. It's all based on the same simple principle that lets a paper towel soak up a spill. Yeah, it's an everyday concept, but it's being used to crack a massive 200-year-old engineering problem.
And this is the number that matters. $1.50 per kilogram. You could call it the magic number, the holy grail. Why? Because that's the price point where green hydrogen, the kind made cleanly from water and renewables, finally beats the dirty hydrogen made from fossil fuels. Hitting this price changes everything.
So to really get why that price is such a big deal, let's do a quick breakdown of the hydrogen family. Most of what we use today is gray hydrogen. It's cheap, but it's made from natural gas and pumps out CO2. Then there's blue hydrogen, which tries to capture that CO2. But the real prize, the ultimate goal, is green hydrogen, made with zero emissions. The only problem? As you can see, it's way, way more expensive. And that is the challenge.
So what is making green hydrogen so darn expensive? Well, get this. A massive 70 to 80% of the entire cost comes down to just one thing: electricity. That huge number tells you one thing very clearly. The process is incredibly inefficient. We're essentially just wasting a ton of valuable renewable energy.
And here's the crazy part. This isn't some new challenge. Scientists have been banging their heads against this same inefficiency problem for 2 centuries. And the villain in this whole story, the thing holding us back all this time, it's bubbles. The official term is bubble masking. So when you're splitting water with electricity, you get these little bubbles of hydrogen and oxygen forming on your electrodes. But here's the problem. They don't just float away, they stick. It's kind of like trying to charge your phone, but you've put a piece of tape over the charging port. The bubbles physically block the reaction, forcing you to waste more and more energy just to get the job done.
Let's just walk through the old, inefficient way. First, you submerge everything in liquid. The second you turn on the power, bubbles start forming all over the electrodes. They cling there, creating this foamy, energy-blocking layer that just suffocates the whole process. So what do you have to do? You have to crank up the power, wasting a huge amount of that electricity as useless heat. It's just a flawed design from the start.
So that brings us to the big question, right? How on earth do you solve a problem that's been stumping engineers for 200 years? Well, it turns out the answer wasn't to fight the bubbles better. It was to design a system where bubbles can't even form in the first place. That's the mindset shift that changed the whole game.
And this is it. This is the breakthrough. It's called capillary-fed electrolysis, or CFE for short. It was developed by an incredible team of researchers at Australia's University of Wollongong, and it's a total redesign of how we think about this process.
The design is just beautiful in its simplicity. See, instead of dunking the electrodes in water, they're not submerged at all. Instead, a special porous material wicks up just enough water, yep, like a paper towel, to keep the electrodes perfectly moist but never flooded. So when the water splits, the hydrogen and oxygen gas just escape directly into dry chambers. There's no liquid for them to bubble through. The problem is just gone.
Okay, so an elegant design is one thing. But what about the results? Well, by completely eliminating bubbles, this technology doesn't just nudge the needle on efficiency, it absolutely shatters all the existing records.
95%. Let that sink in for a second. That is the overall system efficiency they've achieved. Now, keep in mind, conventional systems have been stuck down in the 65 to 75% range for, well, forever. This is a massive, massive leap forward.
So what does that 95% efficiency actually mean in the real world? It means the CFE system only needs 41.5 kilowatt-hours of power to make 1 kilogram of hydrogen. That is a huge drop compared to the best systems we have today. In fact, it's so efficient it has already blown past the International Energy Efficiency Target for the year 2050.
But here's where it gets even better. It's not just about efficiency. The next best technology, PEM, needs super rare and expensive metals like iridium to work. This new CFE system, it runs on cheap, abundant stuff like nickel and iron. And because the design is so simple and passive, it completely gets rid of all the complex pumps and separators. It is just a radically simpler and cheaper machine.
And this is absolutely crucial. The savings go way beyond just the electricity bill. When you get rid of all those complicated moving parts, the pumps, the tanks, the pipes, you slash the upfront cost to build the plant in the first place. And on top of that, you dramatically lower the maintenance costs for its entire lifespan. Now, I know what you might be thinking. This sounds great, but is it just some cool experiment stuck in a lab? The answer is no, not even close. This technology is moving from the lab to global, industrial scale at a truly incredible speed.
A company called Hysata was spun out to bring this tech to the market, and the momentum is just undeniable. They've already locked down $172 million in funding from huge players like BP Ventures. They're in the process of building a gigawatt-scale factory, and they already have a pipeline of more than 9 gigawatts in orders from companies that want this technology now.
I mean, just look at how fast this is all happening. The original research paper only came out in 2022. Just 2 years later, they've got massive funding, partnerships with industrial giants like the steelmaker POSCO, and pilot projects lined up around the world. And by 2026, their huge factory is planned to be up and running. That is lightning fast.
So when you put it all together, the breakthrough science, the huge investment, the incredible speed, it's all driving toward one single clear goal: to completely flip the economics of energy. The mission is to make clean, green hydrogen the cheapest, easiest, and most logical choice for cleaning up the toughest parts of our economy. We're talking steel, shipping, the whole shebang.
So, I'll leave you with this thought. This technology puts us on a direct path to a world where clean fuel is cheap fuel, maybe a decade sooner than anyone thought possible. The question isn't really if green hydrogen can compete anymore, it's when. And when the cleanest fuel also becomes the cheapest fuel, what do you think changes first?